morning, class. Welcome to today's lesson, a very interesting lesson. My name is Francis, because I can see we have a new student at the back there. Now, our lesson is interesting because of how it borrows from our previous lesson. Let's start with a recap of the previous lesson. John, what did we learn in the previous lesson? Yes, that is very good. That the area of a rectangle is a product of its length and its width. Is that so, Jen? Yes, that's very good. Now, on that note, I remember I told you to come with a rectangular piece of paper whose length and width are labeled. Do you have them? That is very, let me see them. Now, I want us to start with a very simple exercise. I want us to cut our rectangle into two along its diagonal and see what we get. Just cut it. Just cut it. What do you have, Maxwell? Good. That is two right-angled triangles. It means we are getting a right-angled triangle from a rectangle, and that forms the base of our lesson today. Our lesson is on finding the area of a right-angled triangle, and the objectives are as clearly displayed here. There are three. Now, back to the example, or back to the exercise on a rectangle. We had a rectangle which had a length and a width. We cut it into two, got two right-angled triangles, each with a base and a height. It therefore means that we can obtain a triangle from a rectangle. Maybe the question that I can ask is, look at my triangle. How can you compare the area of the shaded triangle with that of the rectangle? Maxwell. Good. The area of the right-angled triangle is a half that of the rectangle. That means we can derive the area of a right-angled triangle from the area of a rectangle. If we divide the area of a rectangle by 2, we get the area of a right-angled triangle. Therefore, we can have a formula where the area of a right-angled triangle is given by a half times its base times its height. Now, this formula and this knowledge is important in our real life. For example, in your house, you may have a floor area which is a right-angled triangle that you want to cover with a carpet. To estimate the area of the carpet that you require, you can use this formula as it is. Now, I want us to do some examples on the same so that we can get the concept better. Our first example is on a triangle whose base is 12 and height is 6. To calculate the area, we need to take a half, multiply by 12, and multiply by 6. If you multiply a half by 12 and 6, Janet, what do you get? That is 36. That's very good. That the area will be 36 square units. Now, to put some more practice, I want us to go to our groups of 2 as usual and solve this question where the base of this triangle is x, the perpendicular height is 9. Remember, this height has to be perpendicular, and the area is 108. What will be the length of the base x? Let's work it out. Okay, let's see. Yes, you're doing well. Carry on, carry on, carry on, carry on. Wow, do you have an answer? Janet's group, what did you get as a value of x? 24 meters. Good. Jane's group, what did you get? Still 24. Do you have a group with a different answer? No. Okay, you are all correct, and that's very good. Reason, the area, that is the base x, is 24 centimeters, as can be seen here. You equate 108 to a half times the base that is unknown times the height of 9. This gives you 24 meters as our answer. Not centimeters, but meters. Now, let's handle this now on our own without the group. Just work it out on your own. The base of the triangle is 18 and the height is 10 centimeters. What will be in the area? I want to see what you do there. Okay, you can see you doing well. All right, we have an answer. Let's hear it from John. 90 square centimeters. Good. Jane, 90. Emily, still 90. Do you have someone with a different answer? No, you are all correct. That's very good. The area of this triangle will be 90 square centimeters. I am very happy. I can see you're getting the concept, but with an assignment, we'll do better. But let's conclude our lesson first. Our lesson, we found that the area of a right angled triangle is equal to a half times its base times its height. Our assignment will be in two phases. One, I want you to research whether this same formula can be applied in finding area of other types of triangles such as isosceles and equilateral. And also, I want you to go to page 22 of our text, then solve questions 1 to 5, so that by the time we meet next, you'll have completed that and will be using it. That is very good for today. I'm happy for you. Have a good day and a great week.